Okay, now we're ready for some practice problems. You need to have your calculator close by, which I see mine across the room. I'm going to go get it. Get your calculator ready, because the first thing we're going to do is practice with our calculator. And so making sure we're in the correct mode, degrees versus radians, and how to learn some new buttons on our calculator now that we've been introduced to sine, cosine, and tangent. So let me grab my calculator just a sec. Okay, and so what we're going to do is we're going to learn to press the right buttons. Okay, so here we go. I have a scientific calculator, and so what it tells me is I need to know what mode I'm in. So you have to press the mode button to find out what mode you're in. So in this one, on this particular one, if you can see my screen, it'll say DEG at the bottom, meaning that I'm in degree mode. So that means I am ready to calculate the ratio, the sine ratio of 30 degrees in degree mode, because that's what my calculator's in. If I need to change modes, let me look real quick where it tells me how to change modes. That is FD. Hang on just a second. I don't use this one as often. Let me find here. Oh, right here. I pressed this DRG button, and that gave me degree radians. I can just toggle to the right, radians, and hit enter, and then I'll be in radian mode. It'll say RAD at the bottom. But I want it to be in degree mode, so I'm going to hit this DRG button, and I want to put it back in degrees, and I'll hit enter, and that's what I want it to be in. Now, I'm going to clear off my calculator. I got it in the right mode, and I'm just going to press the SIN, that's the sine button, on my calculator. So I'm going to say the sine of, and I'm going to enter 30, and I know it's in degrees, and so I'll get 0.5. And so this is something that we will end up memorizing, that the sine of 30 degrees is 0.5 or 1/2. And that's always going to tell us if we're in the right mode, if we memorize that. And there's other, that's not too hard to memorize. The sine of 30 is 1/2. The sine of 30 is 1/2. Maybe you have it memorized by now. But that's one thing we need to know. The cosine of 30, let's go ahead and figure out what that is. The cosine of 30, and we're going to do this in decimals. We'll round to 3 places. So let's see, press cosine and say 30 degrees and hit enter, and you get 0.866. 0.866. And then let's find out what the tangent of 30 is. Press TAN and then say 30 and hit enter, and you're going to get 0.577 if we round it to 3 places. By the way, if I say round to 3 places, what we have to do is look 4 places out. So after this is a 3. Since that was, if anything less than 5, 4, 3, 2, 1, this is going to round down to this. If it was 5, 6, 7, 8, that would bump this 7 to an 8. So that's just a little rounding. Okay. Now, if they say the sine of 30 radians, we haven't really talked about radians, but we will soon. That's a different way of calling out angles. And so you want to change your mode to radians. So I'm going to do that. I hit my DRG button, and then I'm going to toggle over to radian, and I'll hit enter. And then now I know it's in radians. It'll give me at the bottom, it says RAD down here. So what is the sine of 30 radians? Say sine, hit 30, enter, and that gives me negative 0.988. Very different number, negative 0.988. This will make more sense when we learn more about radians, but this is the main thing I need you to know right now. Sometimes they will actually write RAD for radians. Most of the time they won't. So how will we know right here, do they want us to do the cosine of 30 degrees or the cosine of 30 radians? I know this means radians, and the reason is they didn't write a degree symbol. It's just a blank. When they don't write a degree symbol and they don't write radians, it is assumed to be in radians. So if they leave off the degree symbol, radians. That's how we know. So let's see. The cosine of 30 is 0.1542. I'm going to round down to 0.154. All right, and then the tangent of 30 radians is negative 0.64053, negative 0.4053. Since it's a 3, I'm going to round to the 5. Okay, that is the difference in degrees and radians for now on your calculator. Now, put your calculator in degree mode. All of these I want us to do in degree mode just for consistency. So I'm putting this back in degree mode. I hit my DRG, I toggled left to degree and hit enter. Now I'm back in degree mode. So what is this? Do you see this little -1 symbol right there? This means the inverse sine function. This is another function we'll be talking about, but right now I just want to show you these buttons on your calculator. This does not mean 1 over sine. This is a new notation. Sine inverse of an angle does not mean 1 over the sine of an angle. This does not mean the reciprocal. This is a new notation. So this is not what this means. That is nonsense. What this means is the inverse sine. Also, a way to write inverse sine is this. Sometimes they write ARC, the arc sine of theta. This arc sine of theta, means inverse sine. So one way I wrote it like this, and then I wrote it like that. These mean the same thing. Arc cosine, cosine inverse, arc tan, inverse tan. Those mean the same thing. So what you put into this is a value. This 0.217 is not a degree, and it is not a radian. It has no units. It is just a number. And what's going to pop out is an angle. Because I said, make sure your calculator's in degree mode, then the angle that will pop out when we put this in our calculator will be in degrees. If I had said, let's put our calculator in radian mode, then the angle that would pop out after this would be in radians. But it's in degrees, so we know we're going to label our answer in degrees. So the inverse sine of a number is an angle. And we will talk more and more about this later in the course, and it will make more sense. But right now, again, the goal is for us to learn this new notation, inverse sine, inverse cosine, inverse tangent, and to learn these buttons on our calculator. Where are they? Well, they're conveniently located above the sine, cosine, and tangent. Above the sine is inverse sine. Above cosine is inverse cosine. Above tangent is inverse tangent. So we're just going to go through, and you'll have to press your second button. So right here, I want to know the inverse sine of 0.217. I say second sine, and it says, hopefully you can see that, sine inverse. And then I'm going to put in 0.217. Enter, and it gives me 12.532. I'm going to round this to the 10th place. So I put 12.5, and it's important that I put the degree symbol indicating what kind of degree this, what kind of, if it's degree or radians. Let's do arc sine. So I press the same exact button because I know this means the same thing. Ready? So let's see. Inverse sine of negative 0.68 gives us negative 42.8. Negative 42.8 degrees. Okay. Arc cosine, inverse cosine of negative 14.78 gives me a domain error. What's wrong with that? Let me try that again. Oh, I put 14. That would be a domain error. This is 0.14. That's what I did wrong. So let's see. Inverse cosine of negative 0.1478. That should be better. It gives me 98.5. Okay, right here, inverse cosine of negative 0.541. 122.8 is what I'm going to round that to. It was 0.75, but that gets rounded up. Inverse tangent of 8.11. 82.97. Oh, this is tricky. 82.97 degrees. If I round to the 10th place, This is going to round up to a 10, and this is going to round up to 83.0 degrees. All right, inverse tan of negative 6.21 gives me negative 80.85 or 0.9 degrees is how we'll round that guy. All right, that's used with our calculator. Now let's do some practice problems. We just have 3 little practice problems, and here we go. This first example says find the 6 trig functions. So we know that means sine, cosine, tangent, cotangent, cosecant, secant of an angle for the angle theta whose terminal side passes through the point 15, negative 8. So let's draw a picture. Draw an xy axis right here. Here's my xy axis. This is the initial side of my angle, and the terminal side is going to pass through this point. All right, let's think about this. Where is this point? X coordinate is 15, and I'm just kind of ballparking this. 15, and then y coordinate is negative 8, so it's going to be down here somewhere. Let's say this is 15, negative 8. This is point P. So where's our angle theta? Ready? This all the way to there. That's our angle theta. So to find out this trig function, we are going to use the definition. Ready? Well, first, we know that the sine of x, oh, not x, of theta, it's theta, the cosine, the tangent. First, let's just do these. By definition is y over r, x over r, y over x. Remember that definition? So, let's figure this out. What is the y? How far down did it take to get to P? Negative 8. How far across did it get to P? What is our x value? 15. This is our x. This is our y. Equals, I'm trying to write equals x. Now, what does r equal to? Well, this is a right angle. We can use the Pythagorean theorem. So r squared is equal to the r squared, let me just do step by step, is equal to 15 squared plus negative 8 squared. So r is the square root of this. And so we can use our calculator, and we will find out that this is, this is this plus this is 289. So r is the square root of 289. So r is 17. Okay. All right, so here we go. By definition, the sign is y over r, or negative 8 over 17. The cosine is x over r. Oh, wait, that's wrong. No, that's right. Negative 8 over 17. And the cosine is x over r, so that's 15 over 17. And the tangent is y over r, or negative 8 over 15. That's the first 3. I just used the reciprocal functions to figure out the rest. So if the sine of theta is this, then the cosecant, which is its reciprocal, is this flip-flopped, negative 17 over 8. And the secant of theta is the reciprocal of the cosine, so it's 17 over 15. And the cotangent of theta is this flip-flopped, negative 15 over 8. So that's how you can do a problem like that. So for this particular problem, we had to go back to the definition of the trig functions. All right, that's fine. But the next 2 examples, they give us a right triangle, and so we just get to use SOHCAHTOA. So let's do that. Here are the next 2 examples. Hang in there, we're almost done. And then you'll be able to do a lot of problems, because this opens up a whole new set of things that you'll know how to do. These are based on this triangle. So let me write the triangle that it's based off of. I have some triangle here. This is theta. This is A, this is B, this is C. So this means this is capital A, this is capital B, and this is capital C, and this is the right angle. Okay, so here is the first thing we have to do. Figure out what the words solve a right triangle is, because these instructions show up a lot, and we have to know what they mean when they tell us to do this. So, solving a right triangle means to find all the unknown angles and lengths of the triangle. Means to find all the unknown angles and lengths of the triangle. Okay, so that's what solving a triangle means. So, in the next example, it says solve the right triangle. So they didn't give us a picture, but we can always draw one. Solve the right triangle where little a is equal to 42.3 meters and theta is 32.4 degrees. Now, if they don't give you an image, you draw your own. It's fine. So, let's see. Let's just draw our triangle here. Right here. C, A. Oh, I wrote it in the wrong place. So I'm going to try to be consistent here. A, B, what do I call it? This theta, this is little a, this is little b, this is little c. Okay. So, let's see. Let's label what we can. They said little a, right here, is equal to 42.3 meters. And they said theta, right here, is 32.4 degrees. So, what we have to figure out, this is what we know, to finish solving this triangle, what do we have to identify? Well, all of the angles, so we know what angle B is. Angle B they gave us. All right. Angle C was given to us because we know it's a right triangle. Angle A is, we don't know, we have to figure that out. Little a is equal to 42.3 meters. They gave us that. Do we know what little b is? No, we don't. We don't know. Do we know what c is? No, we don't. We have to go figure that out. So we're going to use trig functions to figure this out. You can use the Pythagorean theorem at some points, but I'm going to stick with trig functions because I want us to practice that. So here we go. First, let's figure out what angle A is. This is pretty simple because the sum of all the angles add up to be 180 degrees. So we could say simply 180 degrees minus 32.4 degrees minus 90 degrees. That is how much is left over to be angle A. Or after you've done this a while, you could also just say angle A is 90 degrees minus 32.4 because this is 90. However you choose to think of it is fine. You can do that subtraction, and when you do that subtraction, you will find that angle A is 57.6 degrees. Okay, so now we know what this is. This one's taken care of, so let's see. Let's go ahead. We did this one, 57.6 degrees. Okay, now the only things left of fully solving this triangle is figuring out what the length of B is and the length of C is. All right, so we got to think of a trig function that we've learned that involves some known quantities with some unknown quantities that we can solve. So what I know is I know the side adjacent to this angle. I do not know the side opposite, and I need to know that. So let's think. What is a trig function we know, have heard of, that involves opposite and adjacent? Opposite and adjacent. If you look on your sheet, you can figure that out pretty quickly, that the tangent of some angle is opposite over adjacent. So COTOA can help you figure that out. So we know this. We know that the tangent of 32.4 degrees is equal to the opposite, that's B. We don't know what B is, over adjacent. We do know what that is, 42.3. And we can solve this equation. We're about to do this with our calculator, but before we do that, let's set up another one to help us figure out what C is. I'm using the given information, and that's what I choose to do. We could also have involved angle A. There's a lot of ways to do this, but I'm just going to stick with the given information. I want to involve A and C. Well, A, in regards to this angle, is adjacent, and C is hypotenuse. What trig function do we know that involves adjacent and hypotenuse? Adjacent and hypotenuse, and that would be the cosine. So we can say, okay, here's another thing we could set up. The cosine of 32.4 degrees is equal to adjacent 42.3 over hypotenuse, C. So we can solve this. Now, let's solve this for B and C. Get your calculator out and let's do it. How would we solve this equation? Whenever I have a fraction, I like to kill that fraction. And how you do that is you multiply both sides of the equation by the denominator. So I'm going to multiply this side and this side by 42.3. 42.3. Over here, these cancel. I just have B is equal to 42.3 times the tangent of 32.4 degrees. In my calculator, I make sure I'm in degree mode. So when I turn it on, I see, yeah, I'm in degree mode. So I'm just going to say 42.3 times the tangent of 32.4 and hit enter. And I get 26.8. B is 26.8. And that's in meters, it's a length. So now we have B is 26.8. All right, let's go for C. Kill your fraction, multiply both sides by C times C times C. These cancel, so I get C times the cosine of 32.4 degrees is equal to 42.3. And I'm solving for C, so I want to divide both sides by the cosine of 32.4 degrees. These cancel. Oh, that's a huge degree sign. Sorry about that. These cancel, and so I get C is equal to this ratio. So I take 42.3, and I divide it by the cosine of 32.4, and I get 50.09 or 50.1 meters. And that is my answer to this one, 50.1 meters. All right, now there's one other example. Let's go through that and make sure we know how to do that. So let's solve this other triangle. It says this is the second one. Solve, this is another one. Solve the right triangle where, what did they give us this time? Solve the right triangle where A is 46.2 kilometers and B is 22.0 kilometers. Okay, so let's draw our triangle. They say it's a right triangle, so that helps. We know that much. So draw yourself your right triangle. C is what I'm going to save for the 90-degree angle. So I know that this is little c. A, so what I've called this side is 46.2. B is this side. It is 22.0. So this is angle B, and this is angle A. And so how can we, what do we need to figure out? This is what we need to figure out. We need to figure out what, we know that angle C is 90 degrees. That's what we know. We don't know what angle A or angle B are. We don't know. We know that little a is 46.2. We know that little b is 22.0. And we don't know what little c is. All right, we're going to figure this out. So how can we begin this? Well, I need to know what angle B is. And I need to know what angle A is. Let's see. What I know about B is opposite and adjacent. Opposite and adjacent. So what I'm going to choose to do here is to use a trig function that involves opposite and adjacent, and that is tangent. That involves those two. So let's think about this. What is the tangent of angle B? By the way, I just chose to start with B. I could have chosen to start with A. You could have. That would be fine too. But I just chose B. So the tangent of B is opposite over adjacent. And we know what this is. So we know that the tangent of B is the ratio of 22.0 divided by 46.2. How can we get B? This is where we use our inverse button. We take the tangent inverse of both sides of this. So when you take a function and its inverse, they undo each other. And what we're left with is angle B is equal to the tangent inverse of 22.0 over 46.2. So let's do that. In your calculator, hit second tangent inverse of 22 divided by 46.2. And that gives me an angle of 25.5 degrees. So I know that B is 25.5 degrees. So now we figured out this one, 25.5 degrees. All right, how can we figure out what A is? Well, you could do the same thing. You could do like inverse tangent of opposite over adjacent and find out what A is, or you could just subtract this from 90 because the sum of all the angles of a triangle add up to 180. So, and 90 is taken up here. So I'm going to say 90 minus 25.5 gives me 64.5. And that's a real quick way to figure out that. Now, the only thing left to do is C. You could use Pythagorean theorem, but I'm going to use trig functions because I really want to emphasize trig functions because that's what we're learning here. What is a quantity? We know all the angles at this point. And so what is something that involves maybe, if I were to choose B, what if I choose B? I'll stay with B. I need a trig function that involves maybe adjacent over hypotenuse or opposite over hypotenuse. And I'm going to choose maybe just sine. What is the sine? There's a lot of ways to go here. The sine of angle B, 25.5, is equal to opposite 22 over hypotenuse, C. Now I'm going to kill my fraction. C times the sine of 25.5 is equal to 22. I'm going to divide both sides by the sine at 25.5 degrees. These cancel. I get that C is equal to this. 22 divided by the sine of 25.5 gives me 51.1 degrees. Oh, not degrees. That's not right. This is the length of a side. 51.1 kilometers. So once you know every angle and every side of a right triangle, you have solved the right triangle. Later in this course, we'll be solving not right triangles. We'll be finding all the angles and the sides of triangles that are not right, but that's a little bit later.